welcome back to Algebra 1. Our goal for today is to continue working with solving equations, and more specifically, equations that require one inverse operation to help us solve. Yesterday, we reestablished that an equation is a mathematical statement or sentence that has to include an equal sign. So it will always be in the format of I have an expression, an equal sign, and then an expression on the other side. So our goal for today is if we have an unknown or a variable amount in our equation, can we solve using one inverse operation to help us get to our final result? In our last lesson, we only looked at what if my original problem had one add or one subtract in the original problem, which meant it required one subtraction or addition to solve. So for today, we're going to add in our multiplication and division examples. So if my original problem is presented as multiplication, that means my one inverse operation I'll have to do to help me solve will be to divide on both sides of my equal signs. If the original problem is a division, which is going to be presented in the format of one big fraction, then my inverse operation will be to do multiplication to help me solve for the variable. So picking up where we left off in our last lesson, we went through our 4. I have to use subtract to help me solve add problems. And we've already gone through our 4. I have to use add to help me solve subtraction problems. So picking up from there, section number 3 of our note packet, where we are given division problems to start, or what looks like a letter being divided by a number in a fraction. So in this case, just like our last lesson, my suggestion is still focus on this equal sign and find the side where your variable is located and put a box around it. It's not required, it's not a graded thing, but it helps you focus on the side where you need to remove items until you have that variable completely by itself. So inside of our box here, we have a divide and our number is 7. That is what we're going to have to do the inverse operation of. So we need to undo the divide, which means we are going to be multiplying. And with the number that's inside that box with our variable r, which is the 7. Equal sign down the middle. The r divided by 7 goes first. We're going to make a change to it, and that change goes behind, right? I start with what's there, and then I make a change to it. So I need to do the inverse of the divide, which would be a multiply, and the number is a 7. All right, what we did on one side, we got to do the other. So on the other side, we have an 8, and we also have to multiply it by a 7. Now, the reason that this works is over here on this side, when you have a 7 in the denominator, this is technically a 7 in the numerator because it's 7 over 1. Then those 7s are going to do what's called cross-canceling, leaving us with just this variable r. On the other side, we can do the math. 8 times 7 to get 56. So our r value here would be r equals 56. All right, number 2, we have a variable f that's being divided by -3, and the whole thing equals -9. Again, our variable is over here on the left-hand side of our equal sign, so it's going to stay to the left or in front of our equal sign as we solve. Inside of our box here, we have a divide, and with a -3 that we're going to have to do the inverse operation of. So the inverse of the divide will be to multiply, and then with that number, with its sign of -3. So be careful. You're not changing the number. You're doing the inverse of the operation. So if this 3 is negative, everywhere we write that 3 is going to be a negative. All right, what we do to one side, we have to now do to this other side. So -9, we also have to multiply it by -3. All right, on the variable side, our -3s are going to cross-cancel, leaving us with our variable f. Over here, negative times a negative will give us a positive, in this case, a positive 27. So our variable f, in this case, would be the value 27. I can check it. Put 27 in here. We said that this f now is 27. 27 divided by -3, enter. Does it actually give us this -9? If it doesn't, we know we messed up. We should go back and rethink about our inverse operation step. All right, number 3, we want to solve for the variable k here when we're told that -2 equals k divided by 12. Now this one's a little bit different because k is here. It's behind our equal sign. So the variable k is going to remain behind the equal sign throughout our steps. So over here behind our equal sign, we have this k divided by 12. We need to undo the divide with this number 12. All right, so the inverse of the divide is to multiply, and the number is a 12. All right, what we do to one side, we got to do to the other. So over here with our -2, remember the -2 goes first. We're doing a change to it. The change goes behind it. And we want to do that same times 12. All right, on this side with k, right to the right of our equal sign, our k's are going to cross cancel, leaving us with our variable k. On the other side, a -2 times 12, which is -24. So our value of k here is a -24. All right, number 4, we want to solve for the variable f here. Now this one looks a little bit different. It's similar to our problem we did before with a -3. Now this one, the negative sign is out front. Let me just take a side trip over here to the side for a second. -f/3, f over -3, and negative out front, f/3. Those are all the same thing. They all represent the same thing, which is a negative divided by a positive, right? Or a negative value in the end. Now, when you're trying to solve when there's a negative sign, it's easiest to put the negative with the number, right? Since I have all 3 of these options, my suggestion is eliminate the negative out front and just put it here with your number because it means the same thing. As long as there's only one negative sign, one just on the top, one just on the bottom, or one just out front, you're perfectly fine. They all mean the same thing. So right away, I'd say, I don't want it out front. I'm going to put it with my number so that when I do my inverse operation, I'm removing the divide and the negative sign with my number all in one. All right, here's our side that's going to help us. We need to get rid of this divide and with this number now of -3, which means we're going to multiply both sides by -3. So equal sign down the middle. I need to take this 18 and multiply it by -3. And I need to take the f divided by -3 and multiply it by -3. All right, over here on our side with our variable, the -3's are going to cross cancel, leaving us with the variable f. On the other side, 18 times -3 will give us our final value here of -54. Good final. All right, last section. If I'm presented originally with multiplication, I'm going to need a division to help me solve. So number 1, 6y equals 90. All right, now remember, number and letter directly touching, that's a times. So it might help you put that dot or something in there that reminds you. The problem I have right now is multiplication, which means my inverse of that will be a division. Since I need to get rid of a multiply, our inverse of dividing, the easiest way to show it is with a fraction bar. So I bring down my equal sign, I have a 6y, and I need to divide it by 6. Right? So a fraction is the quickest, easiest way in our equations to show that division. What we do to one side, we got to do to the other. So over here with our 90, we also need to divide that by 6. All right, cancel. 6 divided by 6 is just 1, or in this case, 1y, which is what we want. We want 1y left on one side and everything else on the other. 90 divided by 6 then would give us a 15. So our value of y here is 15. All right, number 2, we have 4/5 v equals 28. Now, at first glance, you might say, oh, this is a division because there's a fraction. This problem, 4/5 v, is different from like v over 5 equals 28, right? Those are different. That problem is a 4/5 that's being multiplied with v. This is a v that's being divided by 5, right? Those are different problems and they require different inverse operations, so be careful. So on this side, where our variable is located, we need to remove multiply with this entire number 4/5. So be careful. It's going to look a little goofy because it's going to be a fraction within a fraction for a second because we're going to divide on both sides. So we have our 4/5 that's being multiplied right with our v. We need to undo the multiply, which is a divide, and the number is 4/5. Again, I know that looks kind of goofy right now, but it'll make sense once we do our divide and we cancel things. All right, what we do to one side, we got to do the other. So over here, we have our 28. So we also need to divide it by the 4/5. All right, over here, 4/5 divided by 4/5 will cancel or eliminate, leaving us with a v equals. And then 28 divided by 4/5 would give us a value here of 35. Now it makes a little bit more sense. And I could have gotten a decimal or fraction there, which would be perfectly fine also. All right, number 3, a negative 15 and 66/100 equals 2.7 W. All right, our W is back here behind the equal sign. So when we work with W, it's always going to be on the back side of our equation, so be careful. There's a times here, and our number is 2.7. So we need to undo the multiply with a divide, and with that number, 2.7. So we take our 2.7 W, and we're going to divide it by 2.7. What we did on one side, we got to do it to the other. So over here with our negative 15.66 or 66/100, we also need to divide that by 2.7. All right, equal sign, always straight down the middle of our problem. Over here, 2.7 divided by 2.7 is going to cancel, leaving us with a W by itself behind the equal sign, which is what we wanted. On the other side, negative 15.66 divided by a 2.7 actually gives us a negative 3. Perfectly. All right, we could have done a decimal fraction answer there also. In this case, we didn't. All right, one inverse operation division gets us to our final thing. Oh, excuse me. My fault. This is a negative, mental math's a little off, negative 5.8. And again, we could express that in simplified fraction version if we want, as negative 5 and 4/5 would be the equivalent fraction version of it. All right, last one, number 4. 27 equals negative 9h. Again, our variable h is back here behind our equal sign. So when we work with our variable h, it is always going to be on the back side of our equation, so be careful. So back here, we have a negative 9 that's being multiplied with h. To remove this multiply, we have to divide, and with the same number that is on the side with the variable h, so a negative 9. All right, what we do to one side, we got to do the other. So on the other side, we have a 27 that is also going to get divided by a negative 9. All right, from here, do our divide. 27 divided by negative 9 would give us a negative 3. And negative 9h divided by negative 9, the negative 9s are going to eliminate or cancel, leaving us with our variable h, which is the goal when solving equations. I keep doing inverse operations until I get the variable by itself on one side and everything else on the other. So negative 3 equals h. All right, I hope that helps you attack your work for today.